Okay, on clap. So a couple of months back, when I was writing some code, there was some util class which had some static methods, and it was just getter and setters, which was just in the getters we were getting from shared preferences, उसको रिटर्न कर रहे थे और सेटर में बस शेयर preference में डाल रहे थे. So, कितने लोग कुछ ऐसा कोड करते हैं? सब करते हैं. So it was very tedious यार, मतलब बार बार मुझे वो करना पड़ रहा है. मैं कुछ भी हो सकता है, मैं मतलब आईडी चेंज कर सकता हूँ, कि चेंज द आईडी. So I searched online what can be the solutions. Can it be automated? So after when we heard of automation, we just think of Python. So I thought like we can just make some ये string है, ये basically ये class है, तो वो बस अपने आप convert करना है. But I found out that Java also provides us with annotations and annotation processors. So we can actually use and we can like make a code very concise, and we can do a lot more and save time. And it all actually generates code for us, which is the main reason we are like seeing annotation processors here. So what are annotations? Basically, it's just a form of उसको बस metadata पता होता है. जैसे for example, we have nullable annotation and an override annotation. So what it does is just tells that this method is overridden and is somewhere like upwards, and the nullable annotation is something which tells us कि यार ये null हो सकता है, ये फटेगा, देख लो lint आ जाएगा. So the annotation part, so the nullable and the override is an annotation. The thing you see like the lints, and actually when you write a method and like annotated with override, it will actually not compile, because it will say that it is not overridden. So that part, so that magic is done by annotation processors. So what are annotation processors? A tool for scanning and processing annotations. So basically you have written annotation, now you need a tool to say this is the annotation, these are the components annotated, and do some processing of these annotations. So it's actually a part of the compilation process. So it's actually baked into your Java C compiler. So first, when you hit that compile button, first all the annotation processes like process, generate files, and then the whole files are given to the compiler. Can issue notes, warnings, and errors. The errors is the main thing, because if, for example, we took the example of overrides, if you override a wrong method which is not overridden, it will actually fail to compile. So that is a very big issue, like a big thing, and can generate new source files. So nowadays, in the past 4 years, every library is after this feature to generate code, so we don't have to write it. Take example of Room, take example of Dagger. You just have to annotate. For example, in Dagger, you just have to tell this is the component, these all things I want, and the module, these are how it will be provided, and it just generates the code using annotation processes. So these are the examples. And fun fact, annotation processes was introduced in JDK 5, and the APIs which will be looking was introduced in JDK 6. That was around 2006. So it's it's very old technology, but it's powerful yet. So why should we go for annotation processes? Why not any other route? This is the big thing. No runtime, everything is compile time. It's very effective. We don't want our users to face those bugs. In fact, we can face those bugs. Like the developer, if it will fail, it will not compile, we will be affected, not the user. Also, because if they compile in the compile time, also the compilation is much more faster instead of on the runtime, and also you can miss some cases on runtime. If the code doesn't execute, you don't know it's breaking or not. So this is a very important part. No reflection. We don't need reflection because everything is happening on compile time. Reflection is slow, reflection is error prone. If anybody of you has used reflection to just write one line of code, we have 10 exceptions to be catched. So this is not the right way to do it. This is highlighted because it's the main feature. We can generate boilerplate code, but with an asterisk. Why? Because we can only generate new source files. We cannot like modify an existing file which we have written. So that's the main reason. Like if you have used Room or Dagger, you make a component interface, and that basically the Dagger will generate another file implementing that component interface and actually implementing all the methods. So that is the reason they, or also the Room, they tells us to either use interfaces or abstract classes, because they will generate new classes. They will not more like go to your file and change its code. So these are the 3 reasons you should go for annotation processes. So how does it work? So annotation processes works using these 3 basically components. We'll look at them one by one. Annotation. So first of all, annotation processing tool, APT. So what is the main, what does the APT do? It's basically a part of the Java-C, so everything is compile time. Its main work is to go through each and every annotation in each and every file and gather all the information and give those annotations with specific fields, methods to the respective annotation processes. So how we write our annotation processes, we will write it and we will tell also these are the 3 annotations which I'm interested in. So APT will find all those annotations and will give it to me because I have to do the processing of it. So this is the work of APT. After जब तक दे दिया हमें annotation processes को, we have something called the mirror API. So first of all, there are two types of reflective APIs. One is the reflection API, another one is the mirror API. So you can think of mirror API as a subset of reflection, because you cannot use reflection API at compile time because it's basically runs on the VM. So what it does is it's used to model the semantics. So basically the mirror API will give you exactly how your code is written. So example, if you will mark your activity with activity annotation, for example, so it will give you exactly how it will look. Basically you will get what is the package name, what is the file name, how many fields are there, what are their modifiers, what are the names, if there are any constructors, how many constructors are there, and all that stuff. But you cannot obviously instantiate because it's at the compile time and we are not using reflection. We can just gather information and do whatever we are in the processing, whatever we want to do it. It's represented again, it's represented at the language level. We don't have VM here, and it will just give the how the code is written. And it's only read-only API. Any guesses? Only read-only, because there is no VM. We are just at the compilation level. We can just read the basically code and we cannot execute it. So it's only just read-only. And the last one is annotation processing rounds. This one is very interesting. So let me show you. So what happens is these 3 are your files. We have written some code and you have annotated some fields, methods, etc. So what your annotation process will do some processing and will generate even more code. Now this code also can have annotations. So another round of annotation processing will happen and it will read these annotations and will again generate more files. And also these files can be annotated. So these the process will again happen until no new files are generated, and after all files are generated, our main compilation of the Java-C compilation will take place, and yes, so it will compile afterwards if all the generated files are compilable and it's not breaking. So like that was the basically brief. So in the recap, how it will work is you have APT, annotation processing tool, which will scan for all the annotations in the files, will gather the information, will give it to the respective annotation processors. Then annotation processors will when annotation processors using the mirror API will see what all information is there in the files and how it can process it. Then it will like generate code or have some checks like we saw. After that, the annotation processing rounds, everything will be basically in the rounds, and eventually you will get your generated file and your code will compile. So this was the internals of annotation processor. So let's get started. So Singleton. For the Dagger folks, this is not that Singleton. This is just a class which will be like we will making an annotation processor of it. What we'll do is, if there is a class, if we are annotating that class with Singleton, then there should be two cases. One is all the constructors should be private because we don't want any other, like it should instantiate outside of class. And also, if there is a method named getInstance, it should be static. So so basically, this is a valid piece of code. Our compilation should happen. If it is public location util, then it should break. So let's see how we'll go about this. First of all, we need to write that Singleton annotation. So this is the piece of code for it. So notice that at that interface, this is a keyword which tells us that this Singleton is a annotation. And also in the brackets, you can tell what all the values which can take. For example, if you have used butter knife, we give the r.id for it. So we can tell that how many values, or if it is an integer string, all that stuff will be there. The retention will tell us that this annotation उसको कितना देर तक इसको जिंदा रहना. So I have written source. इसका मतलब it will only be retained at the compile time. I can also use runtime over here. So that means that this annotation will be used we can use it at a runtime, and via reflection we can access the information of this annotation. A good example of a runtime annotation would be your JSON library, because at runtime it converts your JSON to models. So that is an example of runtime annotation. The target, so as I said, we can annotate basically class, constructor, fields, methods. So all that stuff we have to write over here, and it takes an array, not just a single type. So okay, so type here is like class or interface in Java. So we can write type, method, and all that stuff. So how to write your annotation processors? So to write your annotation processors, you have to extend an abstract processor and implement some methods. So the methods which we have to override are these. So let's see one by one. In the first method, init, we will get a processing environment. So processing environment will give us all the utility functions which will help us to process our code. Basically to file, basically to generate classes, to have checks, logger to log messages, all that stuff. Get supported annotations. So as I said earlier, we have to tell it's a compiler these are annotations I am interested in. If you find them, please give it to me. So it's a hashtag. We will return all the annotations we are interested in. Supported version, we can just return the latest supported version. And this is the main one, the process method, which will do all the processing. You will get the annotations, what the annotations were there, and the round environment. Round environment, we just saw it earlier, it happens in rounds. So it gives the information of that particular round, which we have to process. So these are the methods. We'll look at the init method and the process method. The rest is it's there. Init method, we'll get, basically we deal with 4 utility methods. The messenger is used to log messages. So when you find that in the singleton example, when you find that the constructor is actually public, so you have to log the message and show the user that basically it's not, you may make it private. So you will use messenger for this. Filer is to generate like new source code files. Elements and types. So basically these two are the things we use to basically tell. For example, a method is a type. Sorry, a method is an element, and element has subtypes. For example, the method is executable type. So that's basically we deal with elements, and types are basically more generic information. For example, if there is a type of list in generic string, so element will be just be string, and the type will be list of strings. So these basically the differences are in the elements and types. The process method works like this. We get the round environment, we get the elements annotated with. So we get all the elements which are annotated with singleton, but these can be many elements. For example, it can be a class, it can be a field also. So we will filter them like we just want the types. For example, like types means we just want the classes which are annotated with singleton annotation, and then we will like have a for loop for each and every class, and we'll check two cases for check private constructors and check for get instance method. And how we will do that is like this. So first, again, so in the previous slide, as you can see in the for loop, we get the type element. So type element below like gives us the class, and we have all the information about the class in the type elements. So what we will do is in the type element, we will get all the enclosed elements. Basically, it gives all the fields, constructor, and methods. We just want constructor, so we will get only constructors. We will filter them out, and in all the constructors, we are checking like this method, like get modifiers. It should be if it is empty, and yes, so it should be private. If it is not private, we are using the messenger which we like got in the init method. We are just printing a message. Kind error is something which will break the code. It can be warning also, with the warning. It will break the code and a compilation error will occur with this message. And also I'm passing in the constructor. So this is very much needed, because if you get the code and you are passing in the constructor, when you double click on the error message, it will pinpoint, your IDE will pinpoint that this basically constructor is having some issue, please fix it. In the similar way, we are getting the methods over there. We are checking the get simple name. If it is get instance, go further, then basically yes. So these are the types which I was talking to. The type of basically the method return type should be same as the class return type, because that was gets instance do. And we are like again checking the modifiers. It should not be private and it should be static. So like again it's the same cases. And yes, that's it. So our annotation processor is done. We can now, if we will, okay, so now we have like made the annotation processors. Now we need a way to tell the compiler that we have made this annotation process, and please, if you find basically the ABT, if you find any annotations, please give it to me. I need to process it. So for this, there are two ways. There is one old and standard way. You just need to go to basically the source resources. Basically, there is a path meta-inf.services, and there is a file name javax. Basically, there is some file name. It's a big name, and you just have to write the fully qualified name of your processor. So in my case, it was com.Hitanshu singleton compiler .processor. So this way, the compiler will know that this processor is interested, and if I ever find out a singleton annotation, I will call this processor. So now, what is the new way? There is a new library which like Google made. We just have to annotate again. We just have to annotate it with @autoservice processor.class, and it will do the like old work similar. So yes, so that is done. Now we can check. For example, this is the valid code. We have a private constructor and we have a public static get instance, so it will work. But if we just remove basically I've just made the constructor public, so it's showing an error. And also if I remove the static in the get instance method, it's also showing an error. So yes, so it's working.
Hitanshu,
Yes.
can you register multiple processors for a single type of annotation?
Yes, you can.
And in what order are they processed?
So basically in the process method, yes, so in the process method it returns a boolean. So basically what it do, if this is your annotation only, you can return as true, and it will not pass to any other annotation processes. So if you will return it false, then it will like give to the annotation next annotation process who wants to process it.
And which processor goes first? How is that?
Which processor is first? That I don't know. I have to look at it. So there are two ways to register the processor, and yes, so it works right now. So now it was just the checking part. Now we also want to generate new files. So for that, like, there is also a very cool library called the Java Pod library. What it does is, for example, if you want to generate a .java file, it will have a nice API of like builder pattern way of making all the classes, methods, and all that stuff. So let's see how the Java Pod works. Basically, if we want to generate this piece of code, it's a class hello world, and there's just a hello world class. What we will do is this. First we are making a main method. We're just naming it main. It's adding the modifiers public and static. It returns void, adding a parameter, and then we can just add the statements what the method should do. For example, like it's having a t.out.println. So what t stands for is a type. So example, if we have written system dot class, it will just replace it with system, and we have given the class, so it will also import it for us. So yes, so it's easy there. S is for string, so we'll just mention the string. It will replace it with hello Java Pod. So our method is made. Now let's make a class. So class name is hello world. Modifiers here are public and final. Now we'll add the method which was like made here. We are adding here and building it. And at the last, we are specifying the package name and just generating the file. So this is how the Java Pod works. And now I have an example of butter knife. So have you used butter knife here? Yes, good old days, right? So let's see how the butter knife works. Okay guys, so let's see how butter knife works. So let's have a quick recap. So what does butter knife do is, we'll have a main activity class. We'll just annotate with bind view, and we'll tell that this text view is binded to this, basically the ID which you have referred into the XML. So then in the onClick, what you can do is like make a method which will take a view, and you will just annotate with onClick and tell the ID that this is the ID which we want. And in the end, don't forget this, we have to do a butter knife.bind giving the instance of this ID, this activity. So basically what our annotation processors will do, for example, the activity name is main activity, so it will make another class main activity binder. So main activity binder, what it does is, in the constructor. So this is a generated class. I have not made this class. Generated by the annotation processor. So what it does is basically has a constructor which will take instance of the main activity and will call two private methods, bind views and bind on clicks. Then it is one by one will do the main find view by ID and will give inject it to the text view which was in our main activity. Also, similarly, it will also do the find view by ID of the same ID and have register a callback listener, and in the listener it will call the on text to click of the main activity. So this is all done by annotation processor, but there must be a question we are not calling main activity binder from our main activity. We are just calling butterknife.bind. So what actually happening behind the scenes is, this is your main activity, it's having a bind view and on click and bind butterknife.bind. This is all generated. This is all happening in the combined time. So there must be a way to link these two. So there is another file, butterknife. So what butterknife, basically that file, butterknife.bind. It has a bind method which takes in and generates which extends activity, and using reflection, basically we'll call this method, and we are giving the activity, so we can get the main activity, then suffix it with binder, and using the class loader we can load this class main activity binder. So this happens on runtime. So basically runtime we call the bind method. It will go to the method, get the class name, suffix it with binder, basically call the instantiate with this constructor, and then all our views will be binded. So this is how butterknife works. So how I have written the processor of it is like this. So it's quite long, so I'll just show you the main things. So let's see the bind views method. So what bind views is, basically all this code is in the process method, because there is processing. So here we will first make a method, call it bind views, add a modifier is private, return type is void, and add a parameter of activity. So this is our main activity. So we'll add a parameter of it, and in the for loop we will add all the statements, basically all the statements of this, of basically injecting the views. So here we are getting type element, getting closed elements. We only want the fields. So all the fields will be given to us, and we only want the fields that are annotated. So for that we are getting the annotation, and if it is not null, that means it's annotated with bind view. Then we will reach this code and add all the statements. So this is the statement. So we'll one by one, we have written activity in the second argument, it will inject activity. Then simple name means the text view, and just the element means the type, because we have written type here. So this is how basically annotation processor is working. Using Java for it, we can make our own classes, and yes, so it's quite simple. It's not something very extraordinary. Okay, so if you found this talk boring, I've also mentioned, written an article on it. It's a quite long article. It's quite famous also. It was Android Weekly, maybe either annotation processing samples. So all this code which you have seen, including the Singleton and in all the butterknife code, is there on my GitHub like annotation processing repo. And the problem which I told you in the first part, like make all the static methods, which all the getters and methods, I solved it. Please have a look. It's called the project references. You can collaborate if you want. And thank you. This was it.